All right, welcome to the measurement notes in integrated science. Make sure you are on the page after the Milky Mess Lab and make sure you've answered all those questions over your Milky Mess Lab, as well as make sure you have gotten your experimental design worksheet on Schoology finished up. So, measurement. First thing about taking measurements, there are only kind of about 4 different things that we are going to measure in integrated science. We're going to be using a graduated cylinder to measure volume. We're going to use a ruler to take care of length, and remember length would be something like centimeters, meters, miles, feet, inches, stuff like that. Scales will measure our masses, and then a stopwatch or a clock, etc. would be used to measure time. Now, it would be wonderful, really, if we could just all use the same system. However, there's a problem with this. You see, the United States, we use a standard system, inches, feet, pounds, ounces. But the rest of the world, unfortunately, uses the SI or metric system. So what we're going to have to look at is, well, what are the advantages and disadvantages to each system? Well, the advantage to the metric system is almost everywhere else, as we just mentioned, uses the metric system. So when you are traveling between countries, it's nice to have a standard system that you don't have to worry about, are we going miles per hour, or are we going in kilometers per hour? Because those are two completely different numbers. And you could obviously get in big trouble if you are speeding different countries. You have to know the difference between miles per hour and kilometers per hour. In the metric system, it's much easier to go between different units of measurement, because when you're looking at the metric system, all you have to do is move a decimal point. Everything is based off of 10, which, if you would do that, could actually lower the cost of some goods, because you wouldn't have to print the cost in pounds and in kilograms. You would just have one system. The disadvantage, however, is it is definitely a system that some people are not familiar with. If you went up and asked somebody how long is a meter, they couldn't probably tell you how long that is. So it's a system we're not familiar with, and so it would take a lot of getting used to, and there could probably be some mistakes in that. And there definitely would be an initial or startup cost to change those things. So while it may eventually lower costs, initially it probably would be a little bit more expensive. So make sure you do get down a couple of advantages and a couple of disadvantages to switching or using the metric system. All right, so the first thing that we are going to measure in the metric system is volume, and to do this, we are going to use a graduated cylinder. So again, this is measuring volume, and whenever we read a graduated cylinder, what happens is you have this little curve down here. You can kind of see that it dips down and comes back up. Well, this is going to be called a meniscus, and the reason for it is the water just kind of sticks to the glass a little bit, and so it's not straight. Always make sure that you read from the bottom of it. So we want to read from the point that's down here, okay? Not up on the side over here where it would be like, in this case, 15, 16, 17, 18, and like a half if we read the top. This would just be 18 milliliters, okay? So a good measurement in this would be about 18. If you said 17.9 or 18.1, that's fine. But again, it should be somewhere around 18, not quite to 18 and a half, and certainly not to 19. Again, next thing that we would use, obviously we mentioned earlier that rulers are going to measure length, okay? In the metric system, length is going to be in centimeters or meters. The big thing with when we're using a ruler is always to make sure that when you're looking at using a ruler, the end of it isn't always where 0 is. Sometimes you start about here and that's 0. Well, it's a little confusing, so always make sure you line up 0 with the beginning of your measurement. Scales, remember, are going to measure mass. Mass is a little bit different than weight, but I'm not really worried about it. If you said mass or weight, that's perfectly okay. The scale we're going to use, we always want to measure it in grams. Okay, that's different than what the US would use. The US would use ounces or pounds or something like that. we're going to again use grams. Grams are the big thing. Make sure the big one here when actually using a scale is that you zero the scale before you put anything on it that you want to weigh. Stopwatches are next. Remember, those are going to measure time, usually again going to be in seconds. Obviously, if we use something that's going to be a very long amount of time, we might go to minutes, but most of the time we're just going to go seconds. If we're recording, let's say this reading on our stopwatch down here, and I wanted you to record it, you would say this is 7 minutes, 50 seconds, and 44 tenths of a second. Okay? Now, sometimes we're not going to take the time to go through and measure everything directly because we don't need to know exactly what it is. Like the kid with the gumballs down here, we're not going to try to count out every single one. It would simply take too long. So he's going to give an estimate. Oh, there are about 500. Okay, I have no idea. That's probably pretty close though. And again, if the instructions say about, that means you don't have to measure it. Just try to get something close to it. It's a way to go quicker. It's smarter when we're not worried about trying to be perfect on a number. We just need to get something close to it, and it helps us go faster. So, when we're going to worry about estimating things, there's some ways to do this. Since, again, we're not familiar with this system, I'm going to try to give you some little tricks and helpers here. So if I say go out and weigh out about 5 grams, you know how much roughly that is. A gram is about the size of a raisin or a chocolate chip, okay? Somewhere in that range. If I need to get about a kilogram, I can't imagine we're going to use a kilogram, but in case it comes up or you read it somewhere when you're doing projects, etc., kilogram is roughly about 1 liter of soda, okay? A 2-liter bottle is what you're familiar with, but half of that would be a kilogram. So, measuring length, a centimeter is about the size of your fingernail. Okay, so from this side to this side, that would be roughly 1 centimeter. Okay? A meter then, if we're talking a little bit longer distances, a meter is just a couple inches longer than a yardstick. So, when we start talking about meters and yards, those are pretty close to equivalent. But a meter is just a little bit longer. That's why if you look at the track outside and you run a 100-meter dash, you notice it's a little bit longer than the football field, which is 100 yards. Next, if we were to look at estimating volume, a small spoon, about a teaspoon, okay? If you've ever looked on some of your measuring spoons at home, sometimes it'll actually tell you how much it is in milliliters. And a teaspoon is roughly a milliliter. And a liter and a quart, so this is a quart of milk if you've ever seen these. A quart is roughly the same size as a liter. So what we want you to do basically is take a second, go back, make sure you've got everything recorded, and then what we want you to do is go ahead and go to Schoology and fill out your assignment on measurement and estimation.